Hi everybody, this is Ivano Malavolta from the Vrije Universiteit Amsterdam, and in this video I will present our study titled How do you architect your robots? State of the practice and guidelines for ROS-based systems. The main drivers of this research are three. The first one is that one of the main barriers in robotics is at the software levels. The second one is that robotic systems are getting more and more large and complex, involving thousands or hundreds of different components interacting with each other at runtime. There is very little guidance, however, about how to design these kind of systems, and this leads to the need to reason at the architectural level of robotic systems. The intuition behind this study is that we want to observe what practitioners, developers working on real robotic systems are doing on their own systems and how they are architecting them. Then we want to extract what we call design stimuli, that are the main decisions that they take while architecting their own systems, and the applied solutions. Then we want to build a catalog of guidelines for helping practitioners in architecting robotic software. The technological side of this study is based on ROS, which stands for Robot Operating Systems, and it is the de facto standard for developing robotic software. The main research questions of this study are three. The first one is, what are the architecture relevant characteristics of open source ROS-based systems? And this helps both practitioners and researchers in getting an overview, or let's say a snapshot, about real-world robotic software implemented in ROS. The second research question is, what quality requirements are considered when architecting ROS-based systems? And the third research question is, how to guide roboticists when architecting ROS-based systems. The third research question is at the core of the study, and here the idea is to provide a catalog of reusable guidelines for architecting your next robotic system from the perspective of a robotics practitioner. The researcher can use this catalog for getting a foundation on how to develop new approaches for helping practitioners in developing ROS-based systems. The study is designed around two phases. The first phase is about mining software repositories, where we start from more than 80,000 open source software systems. We build a dataset of 335 open source projects, mined mainly from GitHub and Bitbucket. And then we extract the data by looking at all the markdown files in the repositories, all external links and all the stored documents, and by analyzing this data by applying collaborative open coding for the first two research questions, and we go deeper with thematic analysis for answering the third research question. The preliminary results have been refined by closing the loop towards practitioners. So in the second phase, we supply an online survey to 520 contributors to open source repositories. We get 77 answers of this survey, and we use this additional information to check the usefulness of the preliminary results and to see if we can expand the catalog of guidelines according to what the practitioners propose. These are some examples of systems in our dataset. It's quite heterogeneous, both in terms of size, number of contributors, commits, and so on. Let's look at a selection of the main results. The first interesting result is that not all systems have their software architecture well documented. So as we can see here, we have that starting from 335 repositories, 115 actually have some level of documentation of the architecture. Here we can see some examples of documented architectures, and we can see that some of them are based on simple box and line notations. We can have some layered notations, but we can also see what in ROS is called the computational graph. And interestingly, the computational graph is automatically constructed out of a running system. In terms of quality attributes, we can see that maintainability is the most frequent one, followed by reliability, performance, usability, and so on. At the core of our study is the catalog of 49 guidelines for architecting robotics software, and we organize these guidelines around 7 families, depending on the specific concerns that a practitioner may have when working on the system. Families include communication and network, nodes responsibilities, nodes internal behavior, and so on. Okay, here we can see an example of guideline where we say that the behavior of each node should follow a well-defined life cycle, which should be queryable and updatable at runtime. For example, in our dataset, we noticed that practitioners are doing this by including the possible states of a node in its official documentation, or even by enforcing a fixed behavior at runtime. By following this guideline, practitioners can gain in terms of reliability, in terms of testability, and in terms of autonomy. As future work, we are planning to mine architectural tactics for high-quality robotic software. We are planning to perform empirical studies in order to assess how those tactics behave at runtime, especially in terms of energy efficiency, and on assessing how we can automatically apply architectural tactics on robotic software. In conclusion, we know that software is one of the main barriers in robotics systems, but also there is a need in raising the level of abstraction and start to see how these systems can be architected. The study has been designed in a 2 phases way, where the first one is based on mining software repository and the second one involves an online survey. We built a dataset of real robotic software projects, which can be used by the community, and we extracted 49 guidelines for architecting robotic software. The dataset and all the mining and analysis scripts are available in the replication package, which is reusable and publicly available for the community. Thank you.